What if a weapon could find its own target? No pilot, no operator watching a screen. Just launched, and then it hunts. It flies until it picks up a radar signal, locks on, dives. The radar dies, and everything built around that radar, every missile battery, every air defense system depending on it, goes blind in an instant. That's the Harpy. And what came after it was even more dangerous. Today we're looking at two of Israel's most unique weapons, the IAI Harpy and the IAI Harop, the original radar killer, and the version that took that idea much further. Let's go. To understand why these two matter, you need to understand what they're built to destroy. Modern air defense runs on radar. Everything depends on it. Radar detects incoming aircraft, tracks them, feeds targeting data to the interceptors. Without radar, the whole system is blind. Expensive equipment sitting in a field pointing at nothing. Israel asked a different question. What if you didn't need a pilot at all? The Harpy was the answer. Harpy the platform. The IAI Harpy. First shown to the world in 1990. Still in service today. Still being exported. A weapon that has outlasted most of the systems it was designed to kill. Length, around 2.7 meters. Wingspan, around 2.1 meters. Weight, around 135 kilograms. Warhead, 32 kilograms. Endurance, around 2.5 hours. Range, around 500 kilometers. How it works. The operating principle is simple, almost elegant. It launches from a truck-mounted container system. Multiple Harpies ready to fire from a single vehicle. Once airborne, it flies to a designated area. Then it circles, and it waits. The Harpy's radar seeker scans constantly, listening for emissions. Any radar that activates within range, air defense radar, fire control radar, early warning radar, triggers the lock. The Harpy turns toward the signal. Dives, hits. If nothing activates during its patrol time, if every radar in range stays switched off, the Harpy runs out of fuel and the mission ends. But think about the pressure that creates. Export and use. The Harpy has been sold to multiple countries. India operates it. South Korea operates it. Turkey operated it for a period. China reportedly acquired it, which led to a serious diplomatic dispute with the United States when China was suspected of upgrading the system without authorization. Why it changed things before the Harpy. SEAD required aircraft, trained pilots, significant mission planning, and real risk of losing people. The loss of a pilot on a CD mission was an accepted cost of doing business. The Harpy removed that cost entirely. You launch it. It goes to work. If it gets shot down, you've lost a drone, not a pilot, not an aircraft worth tens of millions of dollars, a drone. That shift, removing the human from one of the most dangerous missions in air warfare, changed how militaries thought about the whole problem. And it pointed toward what came next. IAI Harop, the evolution. The Harop is what IAI built after 30 years of operating and refining the Harpy. Same core idea, a drone that hunts radar. But the Harop adds something the Harpy never had, a human operator, a camera, the ability to see, decide, and strike, or choose not to. The platform length, around 2.5 meters, wingspan, around 3 meters, weight, around 135 kilograms, warhead, 23 kilograms, endurance, up to 9 hours, range, over 1,000 kilometers, 9 hours. That number is worth sitting with. The Harop can take off, fly hundreds of kilometers to a target area, circle for most of a day, and still strike when the moment is right. That patience is itself a weapon. It waits, it watches. It picks its moment. 2 modes. Here's what genuinely sets the Harop apart. It operates in 2 modes. In autonomous mode, it behaves like an advanced Harpy. It hunts radar emissions, detects a signal, locks, dives. No operator needed. In man-in-the-loop mode, the operator gets live video from the nose camera. They watch what the Harop sees in real time. They can steer it toward targets that aren't radar emitters, vehicles, buildings, specific positions. They can hold it off a target if the situation changes. They can abort right up until the final seconds. The abort capability. This part deserves specific attention. In modern conflict, Hitting the wrong target carries enormous consequences. Legal, political, strategic. The ability to call off an attack at the last moment isn't just an ethical consideration. It's a practical operational advantage. The Harop can do that. The Harpy cannot. If an operator sends the Harop toward a radar installation and civilians unexpectedly appear near the target, he pulls it back. No strike. Mission aborted. That makes the Harop usable in situations where pure autonomous operation would be too risky. And in the real world, almost every situation is complicated. Combat. Azerbaijan, 2020. The most documented combat use of Harop was during the liberation of Nagorno-Karabakh from occupation in 2020. Azerbaijan used it against Armenian air defense systems. Armenian S-300 radar installations, some of the most sophisticated equipment Armenia operated, were destroyed by Harop strikes before conventional operations followed. Why it matters. The Harop represents a shift in how offensive operations work. Traditionally, clearing enemy air defenses required numerical or technological advantage in aircraft and pilots. Both take years to build. Both cost enormous amounts of money. The Harop offers something different. You don't need more aircraft. You don't need better pilots. You need to find the radar and remove it, methodically, without risking anyone. Conclusion. Two weapons, 30 years apart. The same idea, taken as far as it can go. The IAI Harpy, unveiled in 1990. Fully autonomous, hunts radar and destroys it without any human input after launch. Simple, patient, still flying today. It changed how air defense commanders think about turning their radar on. The IAI Harop, 9 hours in the air, over 1,000 kilometers of range. Two operating modes, autonomous radar hunting or human-directed precision strike. Full abort capability, a weapon that waits, watches, and hits when the moment is exactly right. Proven in 2020 with results the world took note of.